The purpose of this video is to demonstrate the use of the Nanodrop for measuring DNA. And to start, we have a Nanodrop machine, and it's hooked up to a computer. So the first thing we're going to do is turn on the computer. And the password's required by the software, otherwise we wouldn't even have a password. So the password is written on the front of the computer, and it's just SCC Biotech with the caps as indicated. So Control-Alt-Delete, and SCC Bio, and it opens a window, and we're going to open up the software. It says ND 8000, which is for Nanodrop 8000. So we'll open up that program. And you have various options. We can use it to measure protein. We can do microarrays. We can do a number of things. We're going to be using it to measure nucleic acids. So we'll open up the nucleic acids. And the first thing it's going to do, it's initializing with the machine. So it's just making sure that the Nanodrop is connected to the computer. And after that, it'll basically guide you through what it wants you to do. So the first thing that it does is to assure that the pedestals are clean. They should be if it was left properly. And then put water onto the samples. So it needs to initialize the machine using water. And so to do that, we'll open up the Nanodrop. And there are 8 pedestals. All right, 8 on the bottom, and they match the 8 on the top. And we need to add 2 microliters of water to the tops of each of these pedestals. So I have some water. This is purified water. And the way to load this to the pedestal is to take 2 microliters up, and the Nanodrop has grooves in this bar. And it allows you to put the pipette onto the tip, and allows you then to put 2 microliters onto the pedestal relatively easily. So it helps to stabilize. And then the other thing to remember, that as you're doing this, 2 microliters is a very, very small volume, and it will evaporate very quickly. So you want to do this all at one time. You don't want to get distracted, wander through the lab doing something else, because it will evaporate and then will not give you a proper reading or proper assess or alignment with the machine. So I've added water, 2 microliters to each of the pedestals, and I just simply click OK. And so it will initialize then the spectrophotometer. So the Nanodrop is useful for a number of things for measuring DNA. So when we do plasmid preps or mini preps, for example, we may have 50 microliters of sample, and it may have 1 or 2 micrograms of DNA. And we can only use 2 microliters of that to read in here. With a traditional spectrophotometer, we would have to use almost all of that sample in order to get a reading of any significance. All right, so now it has been initialized, and now the instrument is telling us that it must be blanked prior to use. And you want to blank the machine with whatever solution the DNA is in. So if the DNA is in water, we'll blank the machine with water. If the DNA is in TE, which is very often the case, we'll blank the machine with TE. Turns out the samples I'm going to read are in water, and the pedestals already have water on them, so I can just use that to go forward. If I had TE, I would want to take those samples off and put TE on. So it's ready to do the blank, so I'll hit continue, and it will begin the blanking process. So it's going to read the wavelength. Primarily what we're interested in is 260 and 280, but it'll also take a 230 reading. 230 is for protein. 260-280 ratio will give us a measure for the purity of the DNA. All right, so it's finished initialized, it's finished blanking the machine, and now it's ready for us to load samples. And I'm going to go to the manual sample entry, and we'll hit that, and it will show you a plate that looks very much like the plate that's on the top of the Nanodrop. So this plate has lights on it. The lights actually don't do anything other than show you which samples you're going to put into the machine. And so it's on sample 1, and I can give it a sample ID. And this happens to be a plasmid for NF kappa B with a secreted Gaussian luciferase on it. So I can put in the sample ID and click Next Well. And I actually like to do these readings twice. The Nanodrop is a little particular. I do find some variability with it. So if there's enough sample, I would recommend doing 2 readings for each. So I'm just going to put NF kappa B again and go to the next well. And it turns out that I have samples that I've prepared, and I just did a serial dilution. It's not necessary to do a serial dilution usually, as long as you're within a linear range for the machine. But I thought it would be kind of a nice demonstration just to see how well the Nanodrop does with a dilution. So I actually did 1 to 5 dilutions. So I'm just going to call this dilution 1, dilution 1. The next one's going to be dilution 2. And the last one is just water. And I'm finished. Right? It's telling me that the number of active wells doesn't match, although it does. So I don't know why it gave me that. So it's labeled these wells now, NF kappa B, dilution 1, dilution 2, and water for the last 2. And you can tell that they're active because this box will be blackened, so it'll have a black box. The next thing we want to do is put the DNA samples on to measure it. So we have Chem wipes. We have to wipe off the water that's on them. So just simply wipe the bottom and the top to remove the water. And we're ready to load. The loading, if you look on the plate, it'll have A, B, C going from my right to the left. And that matches the A, B, C going from the top to bottom here. So I'm going to be loading from right to left, these samples. So the first one is directly out of my stock. And again, I want to do this fairly quickly. Because I'm going into DNA samples, I'm going to change tips each time because I do not want to contaminate my DNA samples. There we go. I did that one already. So I use 2 microliters. The machine goes to as low as 1 microliter. We'll close it up, and now we're ready to measure. So just click the measure, and it will take the reading. All right, and it will give you kind of a picture of each sample, and that's basically just a scan of wavelengths. And the line in the middle is at 260, which is where DNA absorbs maximally at. And you can see that each of these is aligning with that peak. In the output, on the far right, it'll actually give the concentration, so nanograms per microliter. So we've got 556, 567. I did a 1 to 5 dilution, so we're down at 113 to 109. That's pretty close to 1 to 5. And I did another 1 to 5, and we're getting to 23 nanograms per microliter. So it's relatively close to the way, or to the readings that we might expect for the dilution. To get back to this curve, you want to see this curve where it starts on the left, there's a little bit of dip, it peaks at 260, and then decreases. If you see anything else, so sometimes it might be a straight line, or sometimes it might have a peak somewhere else, that's indicating that the DNA is contaminated with something. It could be protein, it could be RNA, it could be other kinds of things that are going to absorb at that wavelength. One way to get an assessment for purity is to look at the 260-280 ratio. So the Nanodrop will provide that for you. And that 260-280 ratio should be somewhere between 1.8 and 2.0, or in that vicinity. So we can see that the 260-280 ratio here is 2.05, 2.05, 2.14. Getting down here at the lower concentrations, it's got a 2.5. They're in the range, so it's not absolutely pure DNA, but it's pretty close. 1.8 to 2.0 is preferred, is what we would expect to see. And so we've taken our readings, and so the next thing we need to do is to shut the machine off, clean the machine, and get the machine ready for somebody else to use. The step for doing that is to first remove the DNA from the pedestal. So Kim wipe again, just wipe it, both the top and the bottom. And then you can use some water and just spray a little water on the pedestal. Take a Kim wipe and wipe the bottom and wipe the top. Take another fresh one. Wipe the bottom and the top. And I like to put one of the Kim wipes folded up when we close this back up between the top and the bottom. Probably not necessary, but it just keeps the metals from clashing into each other. So we've taken care of this. Now we have to shut off the machine. And we'll shut off the machine. Turns out we want to stay away from the X at the top. For whatever reason, the software doesn't close properly, so we want to use the exit buttons. So we're going to exit. Do we want to leave? Yes, we want to leave. Click exit again. And the same thing for this box. We also want to click the exit. And then to shut the computer off, shut down the computer. And that is all there is to the Nanodrop.